All right. Do you know D3js? So basically, D3js, like, let's start with this. So basically, this talk should not be too much detail and technical stuff. It should be more a little bit inspiring and short. So why would you use it? Maybe get a little bit interested in D3js. Yeah. Do you know D3js? It's basically data-driven documents. What it means. And we can go a little bit into the basics. I will first show what it's all about a little bit, and afterwards go into some details. So data-driven documents from 2011. Currently we are on version 4, and it is widely used over the web because you can very much in detail build your own charts with it. So you are not bound by anything else than the basics of web development, SVG and HTML. Yes. So here are a couple of examples. It's a lot. It's really a lot. You can go scroll down here forever. You have a huge base of examples, tutorials, and a really big community behind it. So whenever you need something, you will very likely find an example for it. So it's really cool. There are everything what you can imagine. Sunburst diagrams, for example, games. No, this is not data. Okay. So I like this one a lot. This is my favorite. This is pretty cool. So D3 is basically a library which gives you a lot of different small packages to work with. So for example, you have geoposition, so you can make hyperbolic geometry and can make really nice animations and visualizations with that. You are not just bound to SVG or HTML, you can also bind it with WebGL or Canvas, for example, if you would like to. So, yes. If you have some time to scroll through, there's really a lot of interesting stuff down here. Let's go back. Yes, you will also find a lot of tutorials for it, so everything is very well explained, which is really cool. So the syntax is a little bit interesting in the beginning, so this is very helpful to have a lot of tutorials by hand, and there is a very good API documentation that you will also find about everything. So it's really cool, a lot of extra features to address when you have to manipulate data to bring it in the right format for your visualizations, for example. And a lot of extra little tools like zooming for your data and other things. Yes. So here's also a complete wiki. Yeah, you will find that also again. And Mike Bostock, the creator, has also its own blog where you can find a lot of interesting things that he's then currently working on now, giving ideas how to write very good quality code in D3. Yes, he is now, basically on D3js there are a lot of libraries already built on top. For example, C3js or NVD.js, some others. And usually the problem is that when you use those, that you have not the configurability that you really want with your charts. So you're forced in a abstract framework that gives you less code and lets you create charts more quickly, but usually you have edge cases that you cannot really cover with it. And that's why it's really cool when you have a project where you have very specific needs for your customer to use D3 directly. We basically build very interactive and charts with very specific details, so that it's not there is not really any other library that can give us to show 10 different signals with 10 different axes, scroll everything around, and then have rectangle zoom and other things in there. So you don't really find this. This is pretty cool. I think this was a force diagram. Yes, so this is now WebGL with D3 layout force. This is one part of the module where you can visualize forces, and this is all mapped into WebGL. So just to show as an example where it's not directly using SVG. Yeah. This was also quite interesting. So this is some D3 visualization together with a surface plot. So you can easily use D3 also with other technologies combined. Yes. So, yep, so a little bit of technical stuff about it. The main thing is selections. This basically means about binding the data to the DOM. This is the main part what usually everybody's talking about with D3. And what it basically means is that you have, maybe I should the other link. Anyway, also works. Anyway, you have your amount of data and you have amount of DOM elements. And when you start, you usually only have an amount of data and you need to map this to your DOM. And for this, D3 gives you three methods, enter, update, and exit, to easily map the amount of data to the amount of DOM elements. So if you have first data, you need to create DOM elements, you just use enter, and it automatically creates them for you. If you have too many DOM elements there, you just call exit, it will just take automatically, and then you can just remove or do whatever, do transitions, and this is really easily doable. And we will later go through an example where we create a complete chart, and then you can see very easily how this actually works. So this is, I would say, with the hardest part to understand, because it's a little bit weird with the syntax, because first what you do is you select the whole DOM, which is basically non-existent at a point, and then you bind it to data, and this is for when you first start with D3, a little bit confusing. Yeah, this was also a very good part on selections, very nice to look at, very good explanation from Mike Bostock. Yeah, the next part, which is really nice, is scales. So this is what you usually use in a chart. You have linear scales, time scales, logarithmic scales, exponential scales that you can directly use, ordinal scales, and you can also bind those to colors, for example. So this is a really nice example where you just have an input space for numbers and you bind this output space then to colors. So basically what a scale is, you just have one dimension, for example, let's say time, and your output dimension might be, for example, the width of your screen, so that you can map this time frame onto your width of the screen. And you usually do this with a continuous scale, and the same you can also, for example, do with colors, and then use different interpolators to interpolate those colors. Yes. So you usually have with all those examples the complete code there, so you can follow it through, and it's really nice. Okay, so basically the most important part about scales are the continuous ones. So basically when you want to map continuous data like time. And the next part, what you usually do with the scales is that you try to show them on the screen with axes, and this is very easily done. In D3 you just have to map your scale object to the axis object, and it automatically generates all the SVG elements for you, and you have complete freedom how to configure those. That's also really nice, so you just have a couple of small commands and then you have the axis already rendered, and don't need to care about all those ticks and everything, it's all taken care of. You can easily change the text or rotation or anything, it's all afterwards easily accessible with selectors. Yeah, you need a line generator if you want to draw paths, for example, and areas. And then a really nice feature is transitions, where basically everything what you do, you can just use the transition on top and it will just automatically animate it. And with tweens, this is really nice. Usually it's enough to just put the transition word in between and it automatically uses default settings to animate it. I will also show something in there. And yeah, maybe some little talk on D3 and frameworks. We currently use D3 combined with Angular 1.6 and we're migrating now to Angular 2. And what we have built is basically it's a component-based system where you have like one parent component a base component for a chart, and you just plug subcomponents, which are all Angular components, into this controller component, and then it builds the chart from that. So you just plug an x-axis component in a y-axis, and then maybe a line render, area render, or what else. So this is all quite intertwined between Angular and D3. It's quite interesting to see, and we made a lot of experiences with it. And in my opinion, I would say keep D3 to itself, so that you have always your chart code in own TypeScript class, or so that it can be work independently from the framework you are using it in. It also keeps you away from debug hell, because when you have digest cycles and everything, it makes it quite hard to debug. You need a really clear life cycle if you have a lot of interactions in your code. Sorry. So let's go to the chart code. So I've created here 12 different charts, and we go from the upper left corner to the bottom right, and I just try to show you a little bit how the code looks like, and there are all the steps explained what we're going to do on the way. So first we are just having some data, which is basically prime numbers, and we want to show them on the screen as a chart. So this is what all the code looks like for the bottom left corner. We basically select our div, which is our container component, container HTML element, and then we append an SVG element. And then we can easily add attributes and starts to it. So this is all usually how you do it.
Can you zoom in?
Zoom in, yeah. Okay. So better to read, yeah? Good. So I just add, for example, a text here as a description, and just give it the normal SVG attributes for that. And usually what you do when you use SVG is that you use a group element to easily make transformations on it, so that you can move it around. And then afterwards, I map my data to those elements. If we go to the index.html file, we will see here's my data. It's just an array of all those prime numbers. And from here, I select all those data points. So this is now the weird thing. You basically select data points, they're non-existent, and you map those to the data. So D3 will now check with the data, and on enter, are there any data points actually available? They are not. So for every array element in the data list, it will now append a circle for you, and then you can also do them at attribute starts as you like. So this is what we do here. We basically added a lot of dots, and afterwards I just do the selection again, and then add the actual Y positioning on the screen. And I just use some fixed value, which is not really nice, and you usually don't want to do this because you are not really flexible. You have a lot of different screen sizes, and that's why we're going to use the scales. So on the next point, what we are going to do is now we introduce a scale, and that scale will scale then all those data, like the dimension space, to this whole height of our available SVG. And this is what you will see, only like 3 lines of code. This is this here, what we do. We just create a linear scale, and then we give it a domain and a range. And the domain is basically the input dimension that we want to map, and this is now with the value from 2 to 7, and then the range is then the distance from 0 to the height of the SVG. And then we just give this while drawing to our data elements. The interesting part here is now, as soon as you map this data to the data points, this data is directly stored on the DOM. So every DOM element that you will select, if you look at it through your console, you will see in specific attribute where this data is directly stored. And with this, we can now when we do a selection on it, we can actually access this data in every callback function. And this way we can use it now with the scale together to actually get the actual Y position scaled to the actual height of the whole chart. Can you still follow me?
Yeah.
Yeah? Yeah? Good. So the next thing what we are going to do is now we're just going to add an axis so that it's visible actually what values are there. So this is also fairly easy. For this we are going to add an axis object. This axis object is just telling us where this axis is, how many ticks in general there should be shown, and how long those lines are. So this is everything that we need to do to generate this axis object. And afterwards we need to create a DOM element where we call this axis on. So this is usually then a group element, and then we just call this axis on it. This is everything we need to do, and we have a complete axis. Then of course you want to do the same for the x dimension, and basically what we're going to do is exactly the same, but then we do it with the actual index of that array. And then you come to this picture. So we are basically just creating a new axis and a new scale, doing exactly the same, and now we are, instead of one time putting always the x position to 0, we are now also updating it with our x scale. So we have now 80 lines of code, and we basically have already our basic chart ready. Then we can also of course start to draw lines there, and this is like the next feature of D3 where we are going to use the path generator. We are basically just creating a new object which is a line function and define which data values should be used. We just scale them. Those are our data values again, and then we call this on a path element that we create, and then the line will be drawn. And then come all the other extra features on top, for example zooming and translation, and this is also already taken care of in D3. So you then create a zoom object, which is this. You can put an extend there, you put a callback on zoom, and then you create another group, another rectangle element or any other element that you can interact with. In this case we take this whole background and then we call this on it. So here we have our div, our SVG, and we call our zoom directly on the SVG, and the magic happens in the background that D3 will add all the event listeners automatically then to the SVG. And for example a wheel scroll for zooming, or on mouse down for panning, and then we can do all those things on every zoom callback. We will just update our scale with an internal command, and everything is done. Just need to call the update function separately. So let's have a look. Update graph. I just update my scales, I update my data, and I update the axis. This is all I need to do. This is all for updating the scales. This is all for updating the data. Just need to reset the Y positioning, and then just call the axis again. And this will automatically update everything. Yes. Another point, what you can see here is now that it's covering over the edges. So for example, you can then add a clip rect, so that's just an SVG thing, that you can cover a specific area, so it's not all visible, so that it's clipped. This is also fairly easy. Maybe we can skip this. And then there are different ways how you can implement this zoom. D3 doesn't really give you one single way how to do it. You can do it as you want. So for example, you can just zoom the whole area, like compared to this. Here we are just really using a transform on the group element to just zoom everything. And you have all the freedom how you want to do it. Yes. So basically here coming then extra features more and more into this picture. We are adding now a tooltip, and for this we have just a mouse over function, and then start bisecting the data and look where's our mouse position, and then we start to move this SVG element around. This can be all accomplished with a very few code, which is really nice. And in the end, we come here to a view where we have 3 different zooms, where we, for example, then have our normal XY zoom, then we have on our axis only axis zoom, and everything can be done separately, and it will be all automatically calculated together within a line, and you can also easily transform everything back into place. It feels a little bit like I have lost you a little bit there, that's why I try to go a little bit quicker through it. Yeah. Okay, here's a quick summary. Yes, it's basically a library providing you a lot of good tools. It doesn't really tell you directly how to do it, so you should give a good look on the examples, but you usually have a very good support there. It is a very good community, good documentation, but one big problem that we usually reach is that you have a lot of long chains of spaghetti code, because you have all those appends and all the attribute changes, so you really need to make sure that you keep your code base nice and separate and clean. And one big issue is that with all the interactions, different components that we have, it's hard to keep the lifecycle clean. So sometimes you have in the end a big decision tree depending on what interactions come, what you really need to update. You want to update as few as possible. So this sounds like a nice way to do it, for example with React, that you could bind this together. But overall, I would say if you really need high configurability and need to rely on features that are not easily accessible with any high-level abstract chart libraries, D3 is a really good offer. Yeah. Any questions? Yep.
Just one note about using it with React. I've done it, and with that you can really create very generic components and create them so loosely that you can do different kind of charts using just very generic components. So of course there is some magic under the hood, so you might end up at some point this debugging hell, but but at least my experience was very pleasant. And there was also very good TypeScript types. So
that's true. Yeah, we use it also together with TypeScript, and there's really good support. That's true.
Thanks. Apart from modularity, what you would say are the nicest upgrades in D3 version 4 compared to version 3?
I would say, let's start, the basics are, a little bit cutting down the syntax. You don't all have the groupings, but what I really like is the new zooming functionality, because this is now easily, how you can more easily keep track of the state in there. So this is really nice. I haven't really used the geo positioning and forces. Usually we're just doing 2D graphs, but this was really one of the nicest features, because we do a lot of zooming, and the state management is not easy when you have to redo, undo all those interactions. Yeah.
Thanks.
All right. I think this concludes our presentations. Thank you very much, Johannes.